Well, the end of this chapter of mechanics of rigid bodies. Let us discuss some problems based upon the various concepts we have discussed throughout this chapter. The problem we are taking now is the impact of the rigid body. This is a stick of mass m and length L, and linear impulse, let it be J, is acting as shown in the diagram at the end of the rod, which is perpendicular to the rod. Find the center mass velocity, angular velocity of the rod, and its kinetic energy. To find the velocity of center of mass, we have to write by assuming this is the velocity of center of mass and omega is the angular velocity of the rod. Impulse, net impulse is equal to change in momentum. That's what our impulse momentum equation says. Net linear impulse, change in linear momentum. Initially the rod was at rest, it gains a velocity Vc. So the change in linear momentum of the rod is m into Vc, and the impulse, net impulse is given, that is J. In this way, we are getting Vc is equal to J by m. Answer. Same impulse momentum equation you have to apply, but here instead of linear impulse, you can write net angular impulse is equal to change in angular momentum. And reference point we have taken about center of mass. About center of mass, the angular impulse is linear impulse into L by 2. And the angular velocity increases from 0 to omega. So the change in angular momentum is equal to about the center of mass is equal to IC into omega. IC is equal to ml square by 12 into omega. And we are getting omega is equal to J upon ml. J upon ml, that is omega. Then total kinetic energy, which is equal to kinetic energy of translation plus kinetic energy of rotation. Translational kinetic energy half mvc square, rotational kinetic energy half IC into omega square. We are applying three different concepts. Vc is equal to J by m and IC is equal to ml square by 12 into omega is equal to J by 6J by ml. Just we are getting J square by 2m plus is ml square by 12 into tau, ये 36 J square by m square L square getting cancelled, m will getting cancelled. We are getting m in the denominator. So 3 by 2 plus 1 by 2, that's equal to J square by m. Answer. So we applied these three concepts. Concept of impulse momentum equation for linear case, in angular case, and concept of translation and rotational kinetic energy. Adding this two, we are getting the total kinetic energy is equal to J square by M. Let us take another example. This example I have chosen from dynamics. Let us take the disk of mass M, radius R, and initially the disk is stationary. Stationary disk is placed on a plank. The plank is moved with constant acceleration, and here it rolls perfectly, pure rolling. This means that at this point there is no relative sliding. In this case, we need to calculate the acceleration of the disk and frictional force acting on the disk. So for this we need to draw free body diagram. Frictional force, let it be backward, we do not know. You may assume forward also. Let us assume that acceleration of the disk is AC and angular acceleration of the disk is alpha. This point acceleration is equal to A. Apart from this, we have the gravity and normal reaction acting on the disk. The normal reaction and gravity, they pass through this point, cannot produce any torque. We are following the basic principle, the center of mass method. Method 1, center of mass reference. Write the equation minus F, F is in negative x direction, is equal to M into AC. Force equation. Then you can just write torque equation. These two force, mg and normal reaction, they pass through the center of mass, therefore they cannot produce any torque about the center of mass axis, and the frictional force can produce a torque, that is F into R in this direction. That's equal to mr square by 2, that is the moment of inertia of the disk with respect to the center of mass into alpha. Direction, torque direction and alpha direction we have assumed are same direction, minus minus k cap. So just we are getting the scalar equation, F is equal to mr alpha by 2. Next we write the kinematical equations. Which tells that at this point, acceleration of this point P is equal to A. A is given as AI cap. AP is equal to APC plus AC. But APC is equal to minus R alpha I cap. AC we have taken ACI cap. We have assumed in this direction. That's equal to AI cap. So AC minus R alpha, that's equal to A. Let us solve the equations. We have three equations. We have three unknown quantities, AC alpha and the frictional force. There are three unknown quantities and three equations, 1, 2 and 3. So from equation 1, calculate AC, substitute here. From equation 2, you can calculate alpha and substitute here to find the frictional force. Using equations 1, 2 and 3. We have from the first equation, AC can be written as minus F by M and substitute here. AC minus R alpha. R alpha will be equal to 2F by M. AC minus R alpha is equal to A. Equation number 3. That's equal to A. A is given. So we are getting minus 3F by M is equal to A. So F we are getting minus MA by 3. So negative sign signifies that our assumed direction should be reversed. Physically, it is evident that the force of friction acting on the disc is directed towards right. That's the idea. And its magnitude is equal to MA by 3. Answer. Once you get the force of friction, then acceleration of the center of mass of the disc we can calculate. AC is equal to minus F by M, but force you are getting this much, minus into minus plus, that is A by 3. Answer. And alpha, when you are getting F equal to this much, minus MA by 3, and that is equal to, or once you get AC, you can substitute here to get the alpha. In this way also you can get. Or you can substitute the force of friction here to get alpha. In both the ways you can get some answer. F is equal to minus MA by 3 is equal to M or alpha by 2. In this way we are getting alpha is equal to A by 3 or minus. Minus sign signifies that alpha will be in reverse direction. So alpha will be in reverse direction. This is the direction of alpha, and this should be the direction of the force of friction. Or if you substitute the value of AC in this problem, in this equation, we can get AC minus R alpha is equal to A. AC is equal to A by 3 minus R alpha will be equal to A. So alpha will be equal to minus 2A by 3 by R is equal to minus 2A by 3R. Are you not getting same answer? So in this way, this is an exciting problem. To use the force equation, the torque equation, and the kinematics of rolling. We can also ask the minimum coefficient of friction required for pure rolling in this case. Find the minimum coefficient of static friction for pure rolling. To solve this problem, we need to write the equation, force equation along y direction, which states that the net force along y direction is equal to N minus mg, that's equal to m into acceleration of the center of mass along y direction, that's equal to 0. So in this way, we are getting normal reaction is equal to weight of the body. Then another one equation we have to write, that is none other than law of static friction, which states that the static frictional force is less than or equal to the limiting static friction. That's equal to mu s into n, and you substitute the value of n. Two additional equations you need to write: the force equation along y direction and the law of static friction. Fs, we have got Fs, that's equal to ma by 3, is less than mu s, n is equal to mg. So you are getting mu s should be greater than or equal to a by 3g. So minimum value of the coefficient of static friction required for pure rolling is equal to a by 3g. That is the answer. Sometimes this problem can be asked a slightly different way. When the acceleration of this plank is given, no need of giving the force acting on the plank. Now, instead of acceleration of the plank, let us apply force F on the plank in rightward direction, and that is given. Instead of acceleration, the force is given, which is acting on the plank, and its mass should be mentioned now. Let us assume that its mass is m, and disk mass is small m. The first problem, find the accelerations both AC and alpha, linear accelerations of the bodies, means both disk and plank, and static force of friction acting if the disk rolls perfectly. Let us assume that the ground is smooth. Then you may add some other questions for this. Find minimum value of mu s. To solve this problem, you have to write the force equation of the disk along x direction, along y direction, torque equation of the disk along z direction. Additional equation you need to write, that is the force equation on the plank, along with the law of static friction if you intend to calculate the minimum coefficient of static friction. Let us draw the FBD and write the equation first. On the disk, let us assume that the force of friction be directed towards the right. If we assume like this, on the plank the force of friction will be directed towards left. Gravity of the disk, normal reaction acting on the disk, normal reaction acting on the plank due to the disk, and normal reaction acting on the plank from the ground and weight of the plank. Let us assume that the acceleration of the disk is a1, acceleration of the plank is A2, and angular axis of the disk is alpha. These are all assumed direction. Bold arrow, force. Bold arrows are representing the forces. Normal arrows represent the acceleration. If you need velocity, you can write dotted arrows. The bit is complete now. Let us write the force equation on the disk. Let us write the force equation on the disk. Along x direction, the force acting is Fs, and that's equal to m into A1. Along y direction, the force will be n minus mg, and that's equal to 0 because along y direction the disk is not accelerating. The disk doesn't accelerate along the y direction. After force equation, let us write the torque equation on the disk. Along z direction, about the center of mass. Normal reaction, the gravity, they pass through the center of mass of the disk, therefore they can't produce a torque about the center of mass. The torque is produced by the force of friction. And we have assumed the force of friction in rightward direction. It will produce a torque in anti-clockwise direction, but we have assumed alpha in clockwise direction. If you don't like it, you can assume in opposite direction also. But according to my assumption, I have to write the diagram. I have to write the equations. I have drawn the FBD by assuming all the directions. These directions of the accelerations are assumed. Accordingly, we have to write the equation. Let us write the torque equation of the disk about the z-axis which passes through the center of mass. The tau c is equal to IC into alpha. Tau c is equal to frictional force will produce anti-clockwise torque, that's equal to Fs into R. If this is a disk, IC is equal to mr square by 2. And alpha, this is plus kf. Alpha I have taken in negative kf direction. So this will give us Fs is equal to minus m or alpha by 2. Same set of equations I have written in the last example. Here we need to write an extra equation for this Planck. For Planck, force equation, net force acting on the Planck is F minus Fs, and that's equal to mass of the Planck, that's capital M into axis of the Planck. Third is fourth equation. We have 4 equations and how many unknown quantities? N, Fs, alpha, A1, A2. A2. 5 unknown quantities and 4 equations. Therefore, we need another 1 equation, and that equation is none other than kinematics of rolling. It states that acceleration of this point along x direction is equal to acceleration of this point q along x direction. Apx is equal to aqx. Acceleration of p with respect to c along x direction plus acceleration of the center of mass of the disk along x direction is equal to acceleration of q along x direction. APC will be equal to minus r alpha I cap. Its acceleration is given as A1 I cap. And acceleration of this point q we have assumed as A2 I cap. So this gives us A1 minus R alpha is equal to A2. Let us now solve all the 5 equations to solve for the 5 unknown quantities. There is a proper procedure of solution also, and that is calculation of the acceleration A1 from first equation. A1 is equal to Fs by m, and substitute A1 here. Calculation of A2 in fourth equation, and A2 will be equal to F minus Fs by capital M. Substitute here in the fifth equation. Calculation of alpha from the third equation. So alpha will be equal to minus 2 Fs by Mr, and substitute this alpha in fifth equation to obtain the value of the force of friction. That is the standard procedure we follow. While doing so, we will get substituting A1 from equation 1, A2 from equation 4, and alpha from equation 3. In equation 5, we obtain Fs by m minus R into alpha will be equal to minus 2 Fs by Mr is equal to A2. A2 will be equal to F minus Fs by capital M. R will be getting cancelled. Minus into minus plus 2 Fs by m plus Fs by m, that is 3 Fs by small m, and Fs by capital M you take it to the side, and in the right hand side we are left behind with the term F by capital M. So Fs 3 by m plus 1 by capital M is equal to 1 by capital M. So Fs is equal to F by capital M by 3 by small m plus 1 by capital M. You can still simplify this factor. That's equal to F by 3 capital M plus M. Let us recheck the steps. Here we have left 2. So let us put 2 here, 2 Fs by capital M. So here you can write 2. So Fs, if you take common, 3 by small m plus 2 by capital M is equal to capital F by capital M. So you are getting F by m upon 3 by small m plus 2 by capital M. So here is a change, 3m plus 2 into small m will be in denominator, and in numerator you are getting small m. So this is the answer. Once you get the frictional force, you can get the value of alpha. Alpha, we are getting positive force of friction, so therefore our assumed direction of friction is correct. Alpha will be equal to minus 2 Fs by Mr. Substitute Fs here. So you are getting minus 2 by small m by R, F into small m, 3m plus 2 small m. So it is getting cancelled. So you are getting minus 2f by r by 3m plus 2 small m. The negative sign signifies that we have to alter the direction of alpha. So the alpha will be outward. Answer. Once you get the alpha, we can find the accelerations a1 and a2. We have got two quantities, fs and alpha. Substituting fs in equation 1, we are getting a1 is equal to fs by m. But what is fs? F small m by 3m plus 2 small m by m is getting cancelled. So this is equal to f by 3 capital M plus 2 small m. Answer. And substituting a1 and alpha, you can get a2. Or substituting fs in this equation, you are getting a2. F minus fs, that is equal to f into m by 3m plus 2 small m is equal to m into a2. So 3m plus 2 small m minus m by 3m plus 2 small m into f is equal to m into a2. So a2 will be equal to f into 3m plus small m by m by 3m plus 2m. Answer. This is a more interesting problem. If the force is given, you need to write some extra steps. But if the acceleration of the Planck, that is a2, is given, then the problem will be simpler and will be falling under the standard of so-called MENS. And if the force acting on the Planck will be given, this will fall in the category of the problems for advanced level.